class. It means today is the fourth physics session that you are meeting me. In that last 4 physics classes, the first class I taught the mathematical tools used in physics, where I taught to you about quadrant system and how to find allied angles, that is sine more than 90, more than 180, more than 170, 270, how to solve those things and come to a conclusion. I taught you that day. In the second session, I talked to you about kinematics basics. Am I right? Second session, I talked to you about kinematics, where I taught to you what is motion, how kinematics has come, from where it has come, and what is motion in 1 dimension, 2 dimension, 3 dimension, and all these things. After that, in my third day, that is last class, I talked to you about vectors. I know last class was a little complicated, little boring maybe, little difficult for you to grasp, because last class was completely new thing. What we learned in the first class was little interesting, second class was relevant, and third class was neither interesting nor relevant, so difficult. But see, don't always expect things to be in your favor, isn't it? You are coming to 11th and 12th class where things will automatically become very challenging for you. So for that, you should have a habit of listening, stressing yourself, and with that stress working hard, not getting depressed, not getting like giving up. I know it is not easy, but the one who keeps on working, that he or she only succeeds. So please keep on working hard. I know you are in your 10th leave vacation now. Even then, I'm expecting from you that you should study something at least. And for what to be studied in this duration, we are helping you out. We are saying you what to study in physics, what to study in chemistry, what to study in math. Believe me, if you are taking all these bridge course seriously, I'm going to have 2 more sessions with you. In this 6 sessions of physics, I'm going to cover at least 30% of your syllabus of 11th itself, the core of that. So when you go to 11th, you will feel it is simple. That was the objective of bridge course. Why the name is bridge course? Because I said to you in the first day, 10th was super easy, 11th is super tough. Bridging the gap between 10th and 11th is only bridge course, and that is possible only if you take this bridge course seriously. And be reminded, check your friends, when they come to 11th, you will see them struggling if they have not attended any bridge course like this anywhere. If it's directly 2 months enjoyed and suddenly appearing in the 11th class, they will feel it is like exponentially tough, very tough. But you, if you are serious for this 1 month, I am assuring you, you will feel, okay, it's not that difficult. Yes, it is big because we are in the class like that, but it is doable. That doable feeling will come inside you because you are attending these classes. That is the aim of this bridge course. Okay. Today's class, once again, can be very interesting if you want it to be interesting. And today's class, we are going to talk about relevant things, but very advanced way. So my today's class will not only cover some concepts of laws of motion, it will also cover the concepts that you are going to use in competitive examination. Today you are going to learn something which you may use if you prepare for any exam like NEET or JEE. I'll go to that level today. You may think bridge course is lesser than 11th level. He is talking about more than 12th level. Then what is going to teach? Let us see what I'm going to teach. Okay. But today my aim is, whether I will do or not, let us see. The 1 hour will tell. But my aim today, with what aim I have come to the classes, I am going to teach you laws of motion from scratch to a level where you can take a JEE question or a NEET question and try to solve. That confidence I want to bring inside you today. That is my aim. Let us see whether I am able to succeed in my aim or not. All your cooperation is required. Srinidhi, your video should not be off. I should not take your name again and again. I will put you in waiting room, nothing else. Okay. So let us start today's class. And today's class, everybody put the heading in notebook as laws of motion. Laws of motion. So I hope everybody knows who gave laws of motion. Famous person, right? Sir Isaac Newton, isn't it? Newton has given laws of motion. First law, second law, and third law, in which everybody in the room will remember third law, without doubt, isn't it? Anybody is there who is not knowing third law of motion? I don't think anybody will be there like that. Everybody who is there in the room, online, offline, front, back, everybody will know third law of motion is to every action there is an equal and opposite reaction. Some of you may remember first law also. First law will be law of inertia. Any object in the state of rest or in state of uniform motion will continue to remain in the same state until or unless an unbalanced force acts on it. You may remember somewhere. Second law, anybody remembers? Force is equal to...
Force is directly proportional to rate of change of momentum.
Very good. I will circle you. I'll come to the point. He said force is equal to... Somebody told here, Darshan told force is equal to mass into acceleration. I have taken his point also. And Mr. Ramcharan, great Ramcharan, has told force is directly proportional to rate of change of momentum. Today we will see all these things. Okay. So first understand the concept of laws of motion starts with the basic understanding of two terms, which are inertia and momentum. So first we'll talk about inertia. What is the meaning of the word inertia? Anybody know what is inertia? Yes, as you said, same thing. So property of the body or the inability of the body to change its state, that inability is called as inertia. If you are sitting on the chair, your body wants to sit on the chair only, at least for now. You don't want to move. If you are made to move, you will show some opposition towards it. That nature of the body is called as inertia. If a body is moving in uniform motion, the body wants to be in uniform motion, not emotionally, analytically. If its state of rest or motion is changed, it will give an opposition to it. That property is called as inertia. Most of you will remember the example from 9th standard. Bus starting, getting a jerk. Bus stopping, getting a jerk. Bus turning, getting a jerk towards one side. That is also inertia. Inertia is of three types: inertia of rest, inertia of motion, inertia of direction. Inertia of rest is body wants to be at rest. Like you sit in the bus and the bus is not moving. Bus suddenly starts, you will get a jerk like this, isn't it? When you are in motion, your body wants to be in motion. Driver applies the brake, you will get a jerk. These jerks that you get when the vehicle is starting or when the vehicle is stopping, you may get a jerk, not jerk, I will say, your body will move towards one side when the bus is rotating. Have you felt it? When the bus or a car is taking a turn, body goes one side. Because what body wanted to be in one direction, you change the direction of it. You show some opposition towards it. These are called as inertia. Now, inertia is a property, it is not a quantity. In physics, I told you before some classes, we will study about a lot of quantities and we will study about properties. Inertia has any unit? No. Inertia has any formula? No. Inertia is just a property, inability of the body. If I ask you what is the unit of inertia? No unit. Dimension of inertia? No dimension. Inertia is a property. Are you getting my point? But one thing I'll tell you. Inertia depends on mass. Though it is not having any formula, but it depends upon mass. That is, object having greater mass will have greater inertia. Common sense. If you want to move a big stone, difficult, right? Its inability is more compared to a small stone which is having less mass. 150 kg person is sitting down and some 40 kg person sitting down. 40 kg, 140 kg. I put whistle. They have to run. Who will be able to run faster? Common sense you are saying, right? Because you're understanding that 140 kg person will have some inability to move. He will also get up and move, but chances of moving is more for whom? A lighter mass. This proves that, not this man example, the stone example proves that inertia depends upon mass. The greater the mass, the greater is the body's inertia. For that, don't write the formula as I proportional to m, I is equal to km. Don't become scientist. Inertia is just depending upon mass. It is not having a formula anything to mass. I hope you are clear in inertia. Inertia is the inability of the body to change its state of rest or motion. It is of three types: inertia of rest, inertia of motion, inertia of direction. There are so many examples I can say apart from that moving bus. You take a cloth which is dirty, hold it, hit by a stick. What will happen? Dust will come out. Why? Why? Inertia of rest. Dust inside the towel was at rest. Suddenly, when you hit by a stick, the clothes came in motion, but the dust was unable to come in motion. Dust remained in the air itself. By gravity, it fell down. Are you able to feel this? Cloth is having dust. I hit by a rod. Cloth started moving towards your right. And the dust could not move. It fell down. Have you seen one kind of amazing video or something? On the table, there will be cloth. All the cutlery will be arranged on the table. A person will come. He will take out the clothes. But the cutleries will not fall down. Don't try this at home. Okay? Otherwise, you will get scoldings from your parent. Don't take my name. Sir told to do that. I am not saying to do that. Try if you want. So if you if you have a cloth and you have a cutlery kept on the table and you are able to take out the cloth very fast from there, it will not fail. You know why? Because the cutlery will have inertia of rest. Before it comes to motion, the cloth will not be there on it. It will not be able to come to motion itself. You take it slowly, everything will fall down. Because by the time it comes to motion, the cloth is still in below it. So it will come in motion, fall down. Are you getting my point? One more experiment I have seen. You keep this thing, a cloth, or maybe a paper or a card on a glass, and you keep a coin on that. Suddenly take out the card, coin will go inside the glass. This kind of videos you would have seen somewhere at least. Social media world. Somewhere you would have seen only in YouTube shorts, Instagram reels. Somewhere. That is the world today. So these things are the best example of inertia, whatever I've told you now. Are you getting my point? Let us talk about the next term today, which is momentum. Now, what is momentum? Anybody remembers? What is momentum? Anybody who remembers?
Mass into velocity.
Yes, it is the product of mass and velocity. Momentum is the product of mass and velocity. Now, this momentum is a quantity. I said inertia is a property, but momentum is what? Physical quantity. Why it is a physical quantity? Because it can be measured. Physical quantities are those which can be measured. Inertia cannot be measured, but momentum can be measured. It is a quantity. And what is the momentum? It is the product of mass and velocity. Velocity being a vector quantity, momentum also is a vector quantity. Remember that. Momentum is a vector quantity because velocity is also a vector quantity. From here you can understand one thing. Since P is equal to mv, I can write V is equal to P by M. Can I write like this? And if P is a constant, can I write V is inversely proportional to M? Can I write this? If it is some constant, it means V is inversely proportional to M. It means if two bodies have same momentum, lighter body will have greater velocity. There are two objects, they are moving with same momentum. Then lighter body will have greater velocity, heavier body will have lesser velocity. I hope you're understanding what I've told now. If P is constant. Got my point? Basic of momentum is clear. Momentum is a product of mass and velocity. Inertia is the inability of the object to change its state of rest or motion. I hope it is clear to everybody. If you want to write something, take 1 minute and copy. If you want to write something, you can copy in 1 minute. Then I will start talking about the laws of motion. Make it fast. I'll erase the board. Priyadarshini, you are sitting in the first class, right?
Yes, sir.
First class of this whole course or physics first class? Whether it is your first physics class or whether it is your first class in this bridge course itself.
No, it's my first class in the course.
Oh, great. Which school you belong to? Which school you belong to in 10th?
Imperial Heritage.
Oh, you are from which place?
I'm from Chennai only, but I live in Delhi now.
Okay, fine. Okay, fine. No problem. We heard that bell rang in your home. You can be unmuted itself. No problem in that. But tell me one thing, that you are going to continue your 11th in the same Imperial Heritage School.
Yes, sir.
But that school is in Delhi or Chennai?
It's in Delhi only.
Okay, which part of Delhi?
I'm actually in Gurugram.
Then you can say Gurugram itself. You are thinking we are not knowing Gurugram, so you are told Delhi. Okay, whatever. Fine. I understood. So no worries. You can unmute yourself. Mute yourself. Shall I proceed further? Okay. So as I said, now we'll talk about the laws of motion. After understanding what is inertia and what is momentum, let us talk about the laws of motion. As I said, there are 3 laws of motion. The first law of motion is also called as law of inertia. Am I right? And this law is very similar to what is the meaning of the word inertia. What this law says? This law says that any object which is in a state of rest or in a state of uniform motion will continue to be in the same state until or unless an unbalanced force acts on it. Now, why did I use the word unbalanced force word? Because it is possible that an object at rest can remain at rest even if the force is acting on it. Yeah, if I apply force here 100 Newton, apply force here also 100 Newton, will the object move? No. So I applied force, object not moved because it is a balanced force. That's why the word unbalanced becomes important. So an object in the state of rest or in a state of uniform motion continues to be in the same state until or unless an external unbalanced force acts on it. This law is called as first law of motion. Very simple, theoretical, no big tension. Second law of motion is what I'm interested in. And second law of motion, some people may not understand today if you have not seen the videos of differentiation still, because we have taught the basics of differentiation earlier. In my class also, in kinematics class, I have taught you d by dx of x power n is equal to nx n minus 1. Basics. D by dx of sin x is cos x. D by dx of cos x is minus sin x. D by dx of x power 5 is 5x power 4. These things, those who are staring me what he is speaking, is because you have not seen the kinematics video properly. Okay? No problem. What is second law of motion? Let us try to understand that. Now, Ramcharan, time came for your test.
Sir,
Yes, you told that force on a body is directly proportional to rate of change of momentum. Am I right?
yes, sir.
Let me correct you, Mr. Ramcharan. Second law of motion. All of you write. It is important. So I'm telling you right. rate of change of momentum is directly proportional to applied unbalanced force. Rate of change of momentum is directly proportional to applied unbalanced force. Rate of change of momentum is directly proportional to applied unbalanced force. Now Mr. Ramcharan will say, sir, what, sir? Same thing I told. You told in a different direction and you are saying I am wrong. Right, Ramcharan?
No, sir.
Then how they are different? What you said and what I said, how are they different?
You're saying is unbalanced force. I said this force.
Leave that. I'm not against you for that reason. I'm against you for some other reason. So understand one thing. Today we are going to learn something very important. Don't forget in your life itself. You are thinking if A is proportional to B, B is also proportional to A. That's what you are thinking, isn't it? All of you are thinking the same thing now, up to now in your life. Okay, let me talk about this. So somebody is thinking, I said, like what he said was, force is directly proportional to rate of change of momentum. But I said rate of change of momentum is directly proportional to applied unbalanced force. Right? So they both are same only. That's what your doubt is. They are different. How they are
constant, it will come down, sir.
Exactly. That is the thing. Now, if A is proportional to B, then A will become equal to what? Some constant times B. So what is A by B? K. And if B is proportional to A, B will become K times A. It means B by A is equal to K. Are they same? How are they same? They can be same. You know when? A and B are equal. When A and B are equal. Very good. When K is equal to 1, I can say. If K is equal to 1, then yes, these two statements can be true. Luckily, Ramcharan, when Newton did this experiment and he removed proportionality, he found that the proportionality value is 1. So, what you are saying is indirectly correct. But Newton did not say this. Newton said rate of change of momentum is directly proportional to applied unbalanced force. When he removed proportionality and added a constant, that constant was K, and that value of K is equal to 1. Since K became equal to 1, I can also write F is equal to dP by dt, isn't it? Since K is equal to 1, I can write F is equal to dP by dt. But in the definition saying F is proportional to dP by dt, K is equal to 1, so F is equal to dP. That is wrong. Because K is equal to 1 was found later. I hope you are getting my point. Mathematically, for the numerical sake, both are same. But conceptually, they both are different. I hope you are getting my point. Not over it. We came to know that force is proportional, or force is equal to rate of change of momentum. After this step, what is the step? D by dt. Momentum is equal to mass into velocity. You may say mass is constant. It comes out dv by dt. Now what is dv by dt? Rate of change of velocity is? Rate of change of velocity is acceleration. I told this in the kinematics class. So F is equal to ma, right? Am I right? Second law of motion. Darshan, same thing you said also. True. If you are studying in 9th standard. What? Oh, don't. Vector symbol is not a problem. There are some more problems. This derivation is not wrong. It is correct. But it is just one part of the derivation. Why? I'll tell you. Because I have assumed mass to be constant. What if mass is not constant? What if velocity is constant? Then what will happen? If velocity is constant, then F will become equal to d by dt of mv, where V is constant, V will come outside, force will become V into dm by dt, isn't it? What is this? How can mass be constant? From my childhood, they have taught me always mass is a constant. How can velocity be constant? Mass be variable. Here I have taken mass as variable, right? Am I right? Because constant definition is 0. So I have taken mass as variable. Can mass be a variable? We have always learned mass is constant. I am saying this is why you are taking different objects. Yeah? Can mass vary? Go to moon, your mass will change. No, right? It will remain same. But what if your hand is cut? Your mass will change or not? You are there. Your mass is 82 kg, 80 kg. I'll cut one of your hands. What will happen? It will become 70 kg. Second hand I also will cut 60. So how can you say mass is constant? Mass can vary. There is a truck going. Truck is carrying 1 lakh. 1 lakh is too big number. 10,000 iPhones. Truck of Apple starting from Bangalore coming to Chennai or going to BKC in Mumbai for delivering the package. And it is having 10,000 boxes of what? iPhones. iPhone 16 Pro Max. Okay? Going. The person who is driving, he is having some setting with some other guy. Okay? He tells, come behind. You come with the vehicle. I will keep on throwing the iPhones. In this case, in this question, I'm not asking whether he will be caught by the police or not. I'm asking whether mass will change or not. Change, obviously. Truck has a mass. Suppose truck has a mass of 10,000 kg. After it was kept on throwing, it will keep on reducing. This kind of numerical, what you will use? You will use the mass as a variable. They will say that mass of the truck is changing at a rate of 5 kg per second. It means every second 5 kg is going out. Possible. 5 boxes throwing every second. Reducing 5 kg per second. If the velocity of the truck should be same, what should be the force applied by the driver in the accelerator? I made a question itself, isn't it? I made a question itself. If there is a truck carrying 10,000 kg of mass moving at a velocity of 50 km/h, a person behind is throwing the articles from the truck at a rate of 5 kg per second. What should be the force applied by the driver so that the velocity does not change? Because what will happen when the mass will be reduced, the velocity will be increased. But he don't want to increase the velocity because from Apple they're checking the velocity of the truck. He don't want to say something is happening. So he is maintaining the velocity constant. To maintain velocity constant, he'll put some brake slowly. So how much force he should apply? That force you can find by using this formula V into dm by dt. Third case is also possible. What is that? Mass is also variable. Velocity is also variable. So we are throwing the boxes out of the vehicle. At the same time, we are not even minding about the velocity. Velocity will keep on changing. In that case, what is second law of motion? F is equal to V into dm by dt plus m into dv by dt, which is equal to ma. So Newton's second law of motion has 3 formula. Till 9th you studied only one. F is equal to ma. It is only valid if what is constant? Mass is constant. If velocity is constant, and this is if both mass and velocity are variable. I hope you understand this. I hope you understand this. Very basic thing, not something hi-fi. So second law of motion is such a big thing. It is not just force is equal to mass into acceleration. Have you cop? Yeah, please ask me, Ramcharan.
I've seen rocket propulsion as an example in NCERT, sir.
Yes.
How it's an example, sir? I don't understand.
Example of what?
For this F equal to ma.
F is equal to ma. See, in the case
I
of
mean
in the case,
mass.
yeah. See what they have told in the what you're talking. I'm understanding. In rocket, what happens when the rocket is leaving above? It is having fuel inside, right, Ramcharan?
Yes, sir.
And the fuel is being thrown below to go up. The propulsion happens,
Yes,
and when the propulsion is happening, the fuel is being burnt. So the mass of the rocket is changing, it is reducing, isn't it?
yes, sir.
So in that question, we will use V into dm by dt if your velocity is constant.
Okay,
Are
sir.
you getting my point? Because their mass is once again changing. And not only there, I hope you know about rocket. If when we are launching anything through by the rocket with the help of any launch vehicle, we have a lot of
They'll remove.
yeah, fuel. This will be there. Catalysis will be there. They'll be removed when it starts moving above. So it mass keeps on changing as it goes above. One thing is fuel being used. One thing is container being offloaded.
Okay, sir.
Yeah. And we have a lot of things about rocket, maybe in the momentum, in the energy concepts. We'll come to that slowly. Not in this bridge course. When the main class starts, that time we will come to that mainly, not now. Can I proceed further? Can I go to the next page? Shall I?
Yes, sir.
Still, I have not started what I thought of starting. Today's topic is free body diagram, isn't it? I'm just teaching you the basics still. I'm yet to start FBD. Can I go to the next page? Final? Thank you. Then comes third law of motion, which is the most easiest one as you think. Right? Third law of motion is the most easiest one in your perception. Most of you will say, yes, I know, sir. To every action, there is an equal and opposite reaction. So F12 is equal to minus of F21. That is, if I am hitting my hand on the wall, I'll also get the pain because I am giving some force on wall. Wall is giving some force on my hand. So my hand will start paining. Common sense, true. So for every action, there is an equal and opposite reaction is true. But believe me, in laws of motion 11th standard, NCERT as well as any NEET or JEE examination, the topic that can trouble you is only third law of motion. Up to now, very small things were there. Now I can teach you for 1 month third law of motion. That much topics are there in third law of motion. Huge syllabus. So let us break down and learn some things today, some small things today. So my today's topic, which is free body diagram, FBD, is purely a consequence of third law of motion only. Okay, let me talk about that. First, let us understand the third law of motion more deeply. If you have an object of mass m, can I say that any force is acting on it? I just told mass is there on the ground. No pushing, no pulling, nothing is happening. If I just
Gravitational force.
gravitational force, very good. That is actually called as weight, mg. It always acts downward, always. Good. Anything else? Any other force is acting? Weight of mg, that is a force only, acting in downward direction. I agree with what Srinidhi told. Anybody else? Do you think? One second. Sai Varshini, please come again.
Sir, I guess frictional force will also be acting in the upward direction.
Frictional force in upward direction. Okay. I don't think you're correct. But today we will talk about frictional force also, but Air resistance. It is flying. Huh? Where air resistance is there? It's not moving also. I have just kept this bottle on the surface. Air resistance is acting. Then think and tell about this bottle. mg downwards, accepted. Anything else is acting? Tell me, Madhuvanti, please. Please be louder.
The table is exerting its force on the top.
Very good, very good, very good. If there is only mg acting, then don't you think the object starts moving down? Whenever an object is having a net force, it cannot be at rest. It will be accelerated. So if there is no other force acting, this object should start going down, no? Will it go down? Is the bottle going down? Why? Because table is giving a force back on it. It is called as normal reaction. Some books will write N, some books will write R. Reaction force. Obviously, it will be there. And what is the value of this reaction force? Same as mg. If there is a 10 kg object kept here, 10 kg means 10 into g. G is how much? 10 approximately. 9.8 very exactly. So 98 Newton is acting downwards. Upward also how much is acting? 98 Newton. That's why that object is able to be on the table, isn't it? Otherwise, what will happen? It will move down. So do you think that whatever mass I keep, it can be on the surface? No. There will be a limit. Beyond that, it will break. If I am keeping the bottle now, maybe some 2.5, 3 kg bottle. If I keep 20 kg, 50 kg, 100 kg, it will break. In this room, 50, 70, 80, I keep 1000 kg, 10,000 kg, 1 lakh kg. What will happen? This will break. So everything, every surface has a limit. That is not the limit of this thing. That is the maximum normal force an object can give for the applied force. Are you getting my point? Whether this will break or not is purely a function of what? N or R, whatever you want to call it. If the object is capable of giving only 10,000 Newton force, then the moment you give 10,001 Newton force in the downward direction, it will break. Isn't it? One more thing I want to ask you. Srinidhi, you told me mg will act downwards, right? Downwards means where, yeah? Where downwards? Where? In the ground. Where? Downwards means where it is pointing. South direction. Think. Good, you told downward. It is true also. But my question to everybody, open to everybody. Where is this downward force? Where? There down means going where? To the center. Core of the earth. Center of the earth. Yes, Srinidhi, you are correct actually. This is kept somewhere on the earth. So the mg, if I am drawing as a diagram, I am drawing down. But actually it is acting like this towards center of the earth. Always remember, earth attracts object towards itself. Where? Towards its center. So whatever object is kept, it will have mg acting towards center. Even if I keep here, where will the mg act? Towards the center. You may say, sir, but then why you are drawing down? Because in this frame of reference, it is acting down only. I am also standing. Do you think that India is there somewhere here? Not right. Somewhere here India is there, no? But am I feeling like I am standing like this? I am feeling I am standing vertically, straight. So when we are talking in this frame of reference, I can draw like this itself. But somebody is seeing this object from the moon. For him, maybe it will be in this direction. I am going a little deep in laws of motion. We will learn that is called as concept of frame of reference. Inertial and non-inertial frame of reference. Very deep topic. Only for competitive examination. But now you understand that if any object is kept on a surface, mg act downwards towards the center of the earth, and for this action, the reaction is normal force acting against the mg, having equal value of mg. Can I say like that? Okay. What if I give applied force? What if I give applied force? Whether some other force will also act? Friction will act. Which direction? Somebody was telling about frictional force. I think Sai Varshini was telling about frictional force. Frictional force, Sai Varshini, will act only if there is an applied force. Remember this. All of you first understand friction and frictional force are not same. Friction is a property. Frictional force is a quantity. Friction means ability of an object to stick with other object. I am standing, I am able to stand here because of friction. But whether frictional force is acting on me, no. Until some force exerts on me. Until you apply a force on an object, frictional force will not come. Frictional force comes only when there is an applied force. So whether frictional force, whether the object will be always moving if there is a force applied? No, depends. If applied force is more than frictional force, it will move. Otherwise, it will be at rest. I am having this big TV. I am applying force of 10 Newton. Is it moving? Not moving. Why not moving? Because my force is less than the frictional force it is applying. If my force would have been more than frictional force, it will move in towards your left. I hope you're understanding this. So these are the forces acting on this object, right? Now, if I ask you, there is a car, or why to go to car directly? Let us go to cycle. There is a cycle which is moving from left to right. All of you pay attention. Cycle is moving from left to right. Draw the forces on it. All of you draw. All of you please draw forces on a cycle if it is moving towards right from left. Cycle is moving to right to from left to right. Draw the forces acting on it. Cycle is moving from left to right. I asked you to draw the forces acting on it. Where is cycle, man? Imaginary cycle. What are those things? Some arrow you have drawn? What is the arrow denoting? Write that. That is cycle? Okay, let me assume cycle. Why dot you? Anybody who has drawn in the online, can you show your notebook in the camera? I'll be able to see here. Please show your notebook in the camera. Whatever you have drawn, yeah, right, wrong, don't worry about that. Whatever you have drawn, can you please show your notebook on the camera? Nobody is showing. Nobody has drawn, huh? Advantage of being in online class. Don't obey the teacher. Yes, Madhuvanti. Difficult for me to see. Can you spotlight her? Yeah, a little above, yeah, little above the your notebook is too down. Little above, little more above, little more above. Okay, fine. Anybody else who is showing the notebook?
Sir.
Yeah. Sarvanaram, please show me. Yeah, good. Sarvanaram. Vinisha is also showing. Okay. Okay. Fine. Okay, let me draw now. Let me draw. First of all, your cycle is moving in which direction, man?
Sir, this right, left to right.
Left to right.
Sir, we should draw the force the person is on exerting.
You should draw the.
The force the person is on exerting.
You can draw if you want to. So there are two wheels generally of a cycle like this. Until you are giving cycle to a 3-year-old toddler having two more wheels to balance it. Otherwise, general cycle will have only two wheels. You are having your own class happening topic there. I am drawing a handle. My drawing is also like this only. And then on the road, if the cycle is going, there are two tires. Both tire will be giving mg, isn't it? You may ask, how much mg? Mass of cycle? Cycle cannot go by itself, right? Towards right. Until you are in a ghost world. Somebody should be sitting on a cycle also, isn't it? So the cycle plus this gentleman sitting on the cycle totally will have some mass. Suppose cycle is 40 kg, the person is 60 kg. So 100 kg is total mass. Ideally, if it is a good cycle made with proper standards, 50 kg forward, 50 kg backward. Generally, it doesn't happen because more weight is behind. That's why the behind tire will get weared off soon, and front tire will be coming for longer life because more mass is behind. So, based upon how much is the mass distributed happening here, I should write M1G and M2G will be acting downwards. For this M1G, upward reaction N. For this, upward reaction N. You may say, why different you are writing, sir? You can write single here N. You can write actually, no problem in that. And then it's moving towards right. So, force must be applied in this direction. And for that, frictional force acting in the opposite direction. Isn't it simple? Clear or not? Okay. Now, the difficulty in this thing is, I have given you cycle, you have drawn a cycle, a person on that and drawn all the forces. If I ask you, draw a free body diagram of a car moving on a mountain, inclined at an angle of 30 degree and draw all the forces acting on it. Now, this will look a little troubling. It's like disturbing you. Or if I ask you, draw the forces on two objects which are kept on triangular wedge combined with a pulley, it will become more uncomfortable for you to draw. Or if I say there are 20 masses hanging by 16 pulleys and single rope, once again it will become tension for you. So to avoid all these kind of problems where drawing, finding the forces becomes complicated, in physics, in mechanics, we use the concept of free body diagram, where we, whatever is given, car is given, human being is given, bike is given, cycle is given, monkey is given, whoever is given. Monkey is actually given, and HC Varma book is there. Why you are seeing him and monkey? I am telling them. Very good. You are in classroom, man. Okay. So, free body diagram can be drawn of any object just by considering it like a small free body. Somebody can even represent like this if they want. I don't have any problem in that. Like what I think Santosh was doing, right? You did like a small dot. See, you did. Okay. But generally what we use is a box kind of thing. And then we start writing all the forces on it. That is downward, upward, left, right, or wherever it acts. This kind of diagram is called as free body diagram. So a diagram which represents all the forces acting on a body is called as free body diagram. Clear to you? Today we will solve, after this half an hour, many questions and many concepts where we will be making use of free body diagram. Now I just told you what is free body diagram. Free body diagram is diagrammatic representation of the object that we are considering, drawing all the forces acting on it. Okay? If I am clear, then let me start talking about the different conditions where we are using free body diagram. Okay? Before I go into that, I should tell you something. That, do you know, if I am having an object and this object is given a force of 10 Newton towards right, and the same object is given a force of 10 Newton making an angle of 30 degree with horizontal. Will the object move for the same distance in both the case or different distance in both the case? Where it will move more far? Where it will move more farther?
Left side first, sir.
What case you're telling? Second case? First case?
Left side. First case.
First case. Okay. Why? Why?
Because there's no angle, sir. Angle of force.
So no angle. So what? You are thinking like that, isn't it? Your gut feeling is saying like that.
Yes, sir.
Okay. Here it is not 0. So. Huh. Huh.
If a place is like this, instead of going like this and like this takes time, but if you're going straight, it is different.
Oh, so you are thinking that if I am pulling in this direction, it will fly and go like this. You are thinking.
Not
Then
take,
more time.
yeah, it differs.
So our human beings, what is the basic common sense says that definitely this is going to be having less force compared to this force. How much less force you are not able to calculate, isn't it? Now you will be able to calculate. Yes, you are right. Our gut feeling is 90% times right only. Here, whatever force you are applying is acting towards right to make the body move towards right. Here, whatever force you are applying is actually getting resolved in two directions. I am talking about resolving of vector quantities. Which side theta is attached, that will become cos component, other will become sine component. So this will become 10 cos 30 degree and this will become 10 sine 30 degree. Remember that any vector quantity, suppose vector quantity is A and this is theta, then this will become cos component, A cos theta, and this will become A sine theta. You should see which side theta is attached. That side will become cos component, other side will become sine component. Now, in this case, what is cos 30 value? Root 3 by 2. So 10 into root 3 by 2 is how much? 5 root 3. Don't you think 5 root 3 is less than 10? Obviously less than 10. Because root 3 is 1.732. 1.7 multiplied by 5 will be definitely less than 10. So the force acting towards right is less. And one more thing happens, you know what? This object weight is getting reduced. Why I say so? Here suppose the mass is 2 kg, then downwards 20 Newton acts, isn't it? 2 into g, mg. And upward, same 20 Newton will act. Are you getting my point? Because normal is equal to reaction. Here what will happen, you know? Downwards 20 is acting, 2 kg mass. Upward 20 was acting for that reaction, and because you applied a force in 30 degree, 10 sin 30 is how much? 10 into 1 by 2, 5. So additional 5 is being given by this itself, so it will become how much? Only 50 Newton is required by normal reaction. 5 is given by whom? The force you applied itself. Because I cannot write 25 there. 25 will mean it is moving upwards. Net force will become 5. Are you getting my point? Not understanding? Confused? We'll understand slowly. Have patience. Everything on one shock, it's not happen. Something should take some time. I'll repeat everything once again. Pay attention. I am trying to say you that suppose on an object I gave a force of some 100 newtons. All the 100 Newton force was used to make the object move towards right. I am assuming friction is 0 here. Okay. But if you give 100 Newton force in this direction, making an angle of suppose 60 degree, then 100 Newton force will not act in the right side. It will resolve in two components. What are the components? 100 cos 60 and here 100 sin 60. It means 100 cos 60 will become 50. Only 50 Newton force is applied towards the right. And 100 sin 60 force is applied towards upward direction, which is actually reducing the weight of the object. Are you getting my point? Why is it reducing weight? Because weight is how much it was acting downwards. Suppose it is 10 kg object, 100 is acting downwards. But in 100, how much it is reducing? 50 root 3 it is reducing. So normal requirement is becoming less. Earlier, this was not there. In this case, only if suppose it is 10 kg body, downward how much was acting? 100 Newton. For how much normal is required? Same 100 Newton normal is required. But now how much is acting downwards? I cannot say 100. Why? Because 10 sin 60 is cancelling it. So out of 100 acting downward, if 100 sin 60, that is actually 50 root 3, cancels, only remaining force will act downward, and for that remaining force only the reaction is required. That's what I'm trying to say in this thing.
100 minus 50.
Obviously, that is the force acting in downward direction, and same reaction upwards. Understanding my point? That is why trolleys are being pulled. Have you ever thought about this? Trolley is there, no? See, trolley has a different concept also. It has wheels, which makes it easy to take it. But why they designed like that? Why can't we make trolley like this? Trolley like this means we are pulling and going, right? Trolley behind. Why can't we make trolley and we push it like this and go? In this direction, the handle is there. Why can't we push and go? Because if you pull and go, this direction force will reduce the weight of the trolley. Vice versa, if you do it, it will increase the weight of the trolley. Are you getting what I'm trying to tell you? So that is one reason why are we designing trolleys. I'm talking about trolleys that are used in going to travel. You take travel, no? You pull it and go. Why don't you push it and go? You pull it and go, right? Always. Because if you're pulling something with some force, there is some component which is reducing its weight. Understanding? Very slowly I'm going, man. Okay. Now, if I ask you, there is a wedge, triangular wedge. I'm going to little complicated scenarios now, okay? Be ready. Those who don't want to be ready, they can leave the meeting also. Here you can sleep also, no problem. But something complex is going to come. Triangular wedge having an angle of theta and an object of mass 5 kg is lying on it. Can anybody dare to draw free body diagram of this? Draw the free body diagram. Assume friction is 0 Assume friction is 0. Don't draw friction. I don't want friction itself. I don't want friction. I assumed surface is frictionless. Surface is frictionless. Now draw the free body diagram of this object. Fast. Ground is like this only for this object, inclined. One hint I'll give you. mg always acts downward. Don't draw mg like this, okay? mg will always act like this only, towards center of the earth. One hint I gave you. Rest is your attention. Drawn. Definitely it will be wrong. Yes, wrong. How you have drawn like this when mg? I told us no, mg will always act downwards. Free body diagram, you can draw if you want to draw there, but free body diagram is separately taking out the body and drawing all the forces on it. So one thing I have drawn for you, which is mg, which is 50 newtons.
We should draw the applied force also.
Is it an applied force?
No.
Then how will you draw applied force? I have entered little complex part of today's class. So now attention is much required. I am very sure that most of you will not be able to solve this. Not your mistake, something new for you, not learned before. Don't worry about it. I'll teach this question to you. I think nobody can solve this. Very frankly, I'm saying. And it is not. Yes, Taruna, please.
Sir, what angle we should take for this diagram?
What arrow means?
Sir, what angle?
Okay, angle you want to take. Good. Angle you can take as 30 degree. What is your wish? You can take 30 degree. You take.
Okay.
Now I'll solve this question for everybody. Please pay attention. Everybody, please pay attention. mg is acting downwards, but normal is always acting against the surface. Remember that. Next is, if mg is acting here, what is this angle? I will say this angle is 30 degree. You know how it comes? Basic geometry. 30, 90, 60. 60, total is 90, it will become 30. If this angle is 30, this is mg, here you will have mg cos 30 and here you will have mg sin 30. So, free body diagram will be downward is 50. We will not write this 50 itself. You know why? Because we have resolved 50 in what and what? 50 cos 30 and 50 sin 30. So, how I will draw is downward, this side 50 cos 30, this side I will draw 50 sin 30, this side I will draw normal force. That's all. Friction will actually act, but I told surface is frictionless. So no need of talking about friction force. Made it simple for you. Is the free body diagram clear?
mg will not act.
mg is only resolving into components here.
We don't need to draw.
Don't need to drawing mg. It will confuse you. You should draw only the final forces. Here I am drawing mg to show you, but there I am not drawing the mg. Not required. Okay. Little bit clear.
Yes, sir.
Shall I go to the next question? Will you try that question?
Yes.
Okay. Now what you do? You try to draw the free body diagram. See, in a question, if you have multiple bodies, you will draw free body diagram of each object separately. Okay. I'll give one question. Once again, assume no friction and draw the free body diagram fast. There are two bodies, 5 and 10. For both, you will draw separately. Make it fast. Any answer you have got? Something you have drawn? I'll come to you. Again, a new concept. All of you will make mistake. So learn that concept. The concept is, when I apply a force 100 Newton, if this 5 and 10 kg body are separate also, after I apply 100, it will go and hit the 10 kg object, and then they both will move together.
Sir,
Yes, Ramcharan.
sir, I got one diagram, sir.
Okay, you just check whether what diagram you have drawn is right or not. Okay, I will just draw it now. You just check whether what you drew is same as what I am drawing or not. Okay.
Yes, sir.
Yes. So when these two bodies are going to move together towards the right, there will be a contact force coming between them. Now, what is this contact force? Every action has an equal and opposite reaction, isn't it? So the moment the 5 will touch with 10, there will be an action reaction. 5 will apply a force on 10, 10 will apply a force on 5, equal and opposite. That's what third law of motion says. Every action has an equal and opposite reaction. Let me name that force as something small f. The small f is what? Small f is contact force I am writing. Contact force. Now, let me draw the free body diagram. Please pay attention. 5 kg separately first I am drawing. For 5 kg, this direction what is acting? 100 Newton. Obviously, downwards what will be there? 50. Upwards, again same normal 50. But is 100, there will be a contact force F here, isn't it? Don't you agree? And on this 10 kg, downward 100, upward n same 100, and this direction F. Action, reaction. Or ulta. Action, reaction. This is the correct free body diagram of both the bodies. If you have drawn the same Ramcharan, you are right. Otherwise, make the changes.
Same diagram, sir.
Okay, you have drawn contact forces? Action, reaction?
Yes, sir.
Okay, good. Then you draw the once again draw. Now you can draw. Very easily you can draw. I taught you, all of you can draw now. So here we will draw 3 free body diagrams, isn't it? 5 separately, 10 separately, 15 separately.
completed.
Good.
So completed.
Good. One thing you should understand, all of you who are doing, the contact forces will be different here. So take, if you're taking F here, F1 here, take F2 there. Don't take same as F. Here the contact force, if I'm taking as F1, here the contact force will become F2. Are you getting? They both will not have same contact force. They'll have different contact force. So 5 kg object, this direction, 500 Newton, this direction, F1, downwards 50, upwards N. Am I right? If all of you have drawn the same thing, then you are right. Same way for a 10 kg object, this side 500, this side not 500 here, F1 will come here, this side F2 will come, downwards 100, upwards N. And for the 15 kg object, downwards 150, upwards N is Newton by the way, this side F2. That's all. Check whether you have drawn the same or not. Yeah. 500? Yes, because this 500 is only creating this F1, F2. So this F2 is coming in the body, no? F1 is coming in the body, no? Who is creating the F1, F2? 500 only is creating the F1, F2. When I will go to the NEET JEE level of question, they will ask you to find the value of contact forces. What is the value of F1? What is the value of F2? No. No. It's not like 500 is distributing inside and becoming same. Even in this case, if you see, I told you that it is having 100, 10 Newton, right? Resolving as 10 cos 30 times sin 3. If you add, will it become 10? No, right? Here it will become 5, here it will become 5 root 3. Add both, it will not be 10. So the force gets resolved. It's not like it's going to be same. It's going to be equal. No. 500 is going to create some force there. But that contact force need not be equal to 500. I hope you're understanding my point. These things will take little time for you to understand. I'm not saying you today itself understand, become brilliant. Whatever I'm teaching is a topic in the 11th standard, which I'm trying to teach you now itself. Because these chapters will haunt you in 11th. Now itself, if you're understanding this little bit at least, when you see during 11th class, it will look familiar to you. That is what my intention is. When you see FBD in 11th now, you will feel, okay, something known to me. Familiarity is the best, most important thing in your studies. Something you feel familiar, you will get confidence. Something you feel new, you will get looser confidence. So I'm trying to make you familiar with things. Are you understanding? There are some more things I thought of discussing with you about pulley system, about tension. Tension means tension and string. But already you are in different tension. So I'm not going to those topics now. Otherwise, it will be more complex things I thought of teaching you today. Okay? Shall I give another question? One last thing to draw a free body diagram. Will you draw? Okay. Try this. Yes.
So there was some network issue.
Okay. Kanishka, no problem. Don't worry, everything is getting recorded. You can see later also if something you have missed. FBD first.
So,
Yes.
so there was network issues on my side. So can you explain the previous diagram?
The previous diagram I will explain now. Let the people write. Everybody copied this? Okay. So the previous question I was saying, where is the question here? We're talking about this question, right? Kanishka?
Yes, sir.
Okay, I said there are three bodies, and these three bodies, if I am giving 500 Newton towards 5 kg, then there will be a contact force developed between 5 and 10, and different contact force will come between 10 and 15. I am taking it as F1 and F2. Then when I solve 5 kg, 10 kg and 15 kg separately, on 5 kg, 500 F1. On 10 kg, F1, F2. On 15 kg, only F2 is acting. Are you understanding?
Yes, sir.
Yeah, take this question, it will be more clear to you. So, try to solve this question. All of you, please.
Drawn, sir.
Drawn?
Sir.
Good. I will draw it, then you can check.
Yeah, sir.
Yeah. This is 20 newtons, which will resolve into two components, 20 cos 30, and decide how much? 20 sine
Sign
30. Same way, this will act how much? 50 newtons. This side you are going to have 50 cos 30. This side you are going to have 50 sine 30. So upwards you are going to have normal here, and here you are going to have another normal. So N1, N2 I am writing. Now you can easily draw the free body diagram, isn't it? Since 5 will go and attach with 2, there will be a contact force coming here. Do you understand that? If they are not moving together, if they are moving separately, then no contact force will not be there. If I am assuming they will join together, because 5 being heavier than 2, definitely at one point they will join together and they will move down. When they are joining together and moving down, then there will be a contact force also between them. So on 2 kg, what are things are acting? This side, 20 cos 30 is how much? 20 root 3. Sorry, 10 root 3 it will be, no? 20 by 5 root 3 by 2. So 10 root 3. This side you have 20 sine 30, which is 10. Upward you have N1, and this side you have F. This is about 2 kg mass. If I talk about 5 kg mass, then what do you have? Downwards you have 50 means 25 root 3. 25 root 3. This side you will have 25. Upward you will have N2, and the same side you will have F. Check if you have drawn the same thing, you have understood the free body diagram.
Yes, sir.
Good. So definitely I did not cover what I thought of covering, but yes, 70%, 80% I covered what I thought of covering. So maybe next session I will be dealing about laws of motion for some time before starting my next class topic. Next class I think I told what, work, energy and power, or gravitation. I don't know. I think work, energy and power, whatever. But whatever I start next class, that I will be starting after teaching some more things from here. Today I gave the base for laws of motion. Next class I will give the complications of laws of motion. Okay?
Yes,
So
sir.
please become a little strong in this free body diagram. Randomly you take something and draw. No problem in that. If you want my verification, come and check with me. Right? And I think the vector worksheet, I told you that we will have a discussion class, because that worksheet will have a lot of doubts. I thought of doing it today at 7 o'clock, I told, but I could not. I had another class happening that time. So I let you know about that class. I will be keeping a separate session to take your doubts from the worksheets that I am giving to you. Okay? Let me plan it and I will put it. Okay, Raghav? When I say that time, we can have discussion class. So let me end my today's class. Today's class, what you learned about what is inertia, what is momentum, first law of motion, second law of motion, and 5% of third law of motion. Only 5%. I told third law of motion is huge, yeah, huge. I just talked very small thing about that. So we will continue with third law of motion in the next class. Meanwhile, go and revise whatever you have learned today. If time permits, take out the 9th standard book and once again go through laws of motion. Okay? It's a simple chapter for you now. But please, I request you, you take out 9th book. If you don't have, if you have thrown your books also, at least from internet you will get easily PDF of the NCERT book. So no hi-fi book required. 9th standard NCERT book, you take it out and solve laws of motion questions given in the book back. That will give some confidence to you in the laws of motion. Okay? Till then, take care. Bye-bye. Good night. We will meet once again in the next session.
And the F should be 25 meters.
F should be?
Thank you.
25 meters.
Which F should be?